Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today we're going to talk about forces and how they affect motion. Here is an example of past AP exam. Block 1 of mass M1 is placed on block 2 of mass M2, which is then placed on a table. A string connecting block 2 to a high mass big M passes over a pulley attached to one end of the table, as shown. The mass and the friction of the pulley are negligible. The coefficients of friction between block 1 and 2 and between block 2 and the tabletop are non-zero and are given in the following table for static and kinetic block 1 and 2 and block 2 and table. Express your answers in terms of the masses, coefficients of friction, and g, the acceleration of gravity. Question 1. Suppose that value of big M is small enough that the blocks remains at rest when released. For each of the following forces, determine the magnitude of force and draw a vector on the block provided to indicate direction of the force if it is non-zero. So here are the situations. Situation number 1, the normal force N1 exerts on the block 1 by block 2. Normal force should be going upward to overcome gravity down, and that magnitude should be equal to gravity on M1, so N1 should be equal to M1g. The friction force F1 exerted on block 1 by block 2. Let's take a look at M1. There is, other than normal force and gravity, there is no other horizontal force. Since there is no other horizontal force and M1 is at rest, there is no friction. F1 has to be 0. Since F1 equals to 0, you can't draw anything. Number 3, force T exerted on block 2 by the string. So the force T on the block 2, it has to go to the right. And how big is this? Let's see. This force, the horizontal tension, has to be equal to vertical tension on the T. This two has to be the same because that's how tension is. Tension is transmitted through the whole rope. And this rope is the mass is negligible, so the tension are the same. The tension on the vertical part has to be equal to big mg because big M is not moving. Therefore, the tension on the horizontal has to be equal to mg. Next one, the normal force N2 exerted on block 2 by the tabletop. Now the tabletop has to support both M1 and M2. So N2, that's upward, its magnitude should be equals to the gravity of M1 and M2 because both are attracted by the earth downward and table has to support both. Next one, the friction force F2 exerted on block 2 by the tabletop. So M2 is not moving, but in this case, there is a friction. The reason for that is because there is a force, tension is pulling M2. If there is no friction, M2 would be moving. So M2 is at rest because there is a static friction preventing M2 moving. So the force on M2, friction force on M2 should be equal to tension. And we know the tension already, tension equals to mg. So F2 equals to tension equals to mg. Some of you probably say, wait a second, I know why can't we use the equation F2 equals to mu s times N2? We can use that equation because that equation is for maximum static friction. We know static friction changes, so this is not the maximum. Okay, let's take a look at the next part. Determine the largest value M for which the blocks can remain at rest. In this case, the largest M, for it to remain at rest, the largest M has to overcome the maximum static friction. So here are the forces. F2 has to be equal to T, has to be equal to mg. So F2 changes according to G, so you can keep adding the mass until that maximum value, so the block will start to move. That maximum value corresponding to maximum of F2. Then that F2s equals to mu s2 times N2, which is M1 plus M2g, that equals to mg. So from here, you can solve for a maximum of M so that the whole system is at rest. Part C, suppose M is large enough so that hanging block descends when blocks are released. Assume block 1, 2 are moving in a unit. determine the magnitude A of the acceleration. So here is the force. We know from acceleration we have to use Newton's second law, net force equals ma. So let's determine the system. If I consider m1, m2, and big M as a whole system, then N2 and M1, M2G cancels out. The net force is just big Mg and F2. So they are in the opposite direction. You subtract it. I have Mg as positive because that's the direction of the whole system's acceleration, minus the friction. This is kinetic friction because both are moving. That equals to total mass accelerating at A. So from here we can solve for A. Next one. Now suppose that M is so large that the hanging block descends, block 1 is slipping. So the friction cannot keep M1 have the same acceleration as M2. So determine each of the following. The magnitude A1 of the acceleration for block 1. So let's do a free body diagram. So here, to find acceleration, again, we use Newton's second law. Let's see what are the forces. We know we have upward and downward force, those cancels. So F1 is the net force, and that F1 is kinetic friction. So that should be mu K1 times N1, which is M1G. And that is a friction force from M2 that's producing acceleration for A1. So from here, we can solve for A1. Part 2 of D is what is the magnitude A2 of the acceleration of block 2? So again, we use net force equals ma. So we just have to find forces. Let's do a free body diagram. Here, so if here is the system, what are the forces acting on the system? So the system, we know up and down cancels. The system on M2 is just big Mg going downward, have to overcome kinetic friction from M1 on M2 and kinetic friction from the table on M2. So big Mg minus F1 minus M2, F2 equals to M2 plus big M A2, because in this case, M1 is not part of the system. So F1 is mu K1 times M1G. Because that is kinetic friction. F2 is mu K2 times N2. So that's again kinetic friction. So we can solve for A2. So A2 is just big M minus mu K1 times M1 minus mu K2 times M1 plus M2 divided by the total mass, in this case is big M plus M2 times G. And that's A2. I hope that helps. And thanks for watching. See you next time.